Next, we will have Liliana Stoian to speak to us about the power of legacy data. Liliana is a senior geologist for Geoscience Databases with a survey. Her role includes managing mineral exploration companies' data, and her involvement in the government initiatives has been crucial as a palynologist, where her contribution has led to the discovery of new mineral deposits such as heavy mineral sands in Eucla Basin and 4 Mile uranium deposit, providing new insight into the landscape evolution of the Mesozoic and Cenozoic era. Please welcome Liliana.
Thank you, Amy. Welcome everyone to my presentation about the legacy data. So I'm going to take you today for a journey from legacy data to the new data releases over the GP2 area, and also showing you some stats over the big area of the state. But first of all, what is the legacy data? In today's presentation, I'm talking about the data stored in the historic and technical reports and envelopes from mineral exploration companies. But a general definition is legacy data we are referring as old information and data, very difficult to access and use, generally stored in outdated or obsolete systems, formats, or technologies. From historical envelopes and technical reports, we have complex data sets for drill holes, downhole geochemistry, lithology, petrophysics, mineralogy, maps, plans, surface samples, geophysics, etc. So in the Geological Survey South Australia, we have over 9,000 envelopes with legacy data, which is not in digital format. So the envelopes, for those who are not familiar with this, contain all companies' completion reports and data from their tenements. So there are some examples there, from old maps to drill holes on the plans, some handwritten envelopes, and the same for the lithology, logs and assay. So we do value the legacy data because we see the role of the government as the custodian of the big data. And we heard today that GSSA Geosciences Database being ranked #1 in the world by the Fraser Institute in 2022. We want to stimulate mineral exploration in South Australia by promoting, evaluating, and releasing and integrating the legacy data with other geoscience data sets, and CERIC is the best place to do it. We want to create a virtual digital core library by transforming physical resources into digital library, allowing cores and all associated data sets to be accessible anytime from anywhere in the world. And of course, we are using the legacy data in collaborative projects like MINEX CRC for NDI drilling initiative in the Delamerian origin, the Goller Challenge competition in 2020, the GP2 we heard yesterday at the workshop, and for the critical minerals potential for South Australia. So the map showing the important mineral deposits in South Australia, we saw this map early today, but we are looking in the legacy data maybe to find more gaps in the data and to find new mineral deposits. We're facing challenges. Nothing is easy when it comes to legacy data. Data quality. We have to check for errors, duplicates, inconsistencies, inaccuracies. Then accessibility. Data is available, but difficult to retrieve specific information within the data. Lithology, logs, assay, handwritten format, petrophysics on graphs, drill holes location on plans to georeference. Then we are facing compatibility with modern technologies. We have outdated formats of systems. Core photos still on CDs and DVDs, and the modern laptops don't even come with these devices. Documents scanned at a lower resolution makes it difficult to read, transfer, or capture the data. And the last one probably is the cost involved to re-examine and reinterpret the original data from all these 9,000 envelopes, to use it with other geoscientific data sets to generate mineral prospectivity maps. So what we are doing with the legacy data, we've done several audits. Between 2019 and 2023, myself and Charlotte Mitchell, we've been doing some audits over the big area of the states, starting with Delamerian, then the Goller Challenge, then the GP2, Cunnamunna and Musgrave provinces. And The scope of this was to identify how much data was captured in the database, how much data is not captured. Then we compare and document the results from the data captured versus raw data submitted. As criteria, we're using the tenement list, mineral exploration tenement list over the areas, associated envelopes, reports, everything we audited, pre-digital, digital, handwritten and non-written envelopes. So we're going to present you in the next couple of slides the results. From the Delamerian audit in 2019, we had 2 months to complete the audit, over 1,124 ELs and 585 envelopes. We audited a big area. By the end of 2019, we get 16,000 new drill holes in the database, and the same 16,000 drill holes with the lithology logs, about 150,000 new downhole geochem samples, and petrophysics for 386 drill holes, and 181 new surface samples with geochemistry captured. All this data are being used by Team WISE and the HIM in conjunction with other datasets for NDI drilling program. Then, Goller Challenge competition back in 2020. Early in 2020, before pandemic, we had 2 months to complete the audit before the challenges started. 2,568 tenements, big job to do, big audit. We did all the stats, as you can see there, the graphs, and we decided that we have to put together the team #1 to collect the data, in particular from these 528 envelopes with the lithology logs. We've been very much behind with that particular data set. So we employed a staff member, Charlotte Mitchell and Kate Pierce, and myself, together with 10 students and graduates supervised by Kate Pierce. The project was running for 6 months during the challenge, and the value this team put together was about 350 million worth of data in today's money. What we delivered? We delivered in database about 18,000 new drill holes and 852,000 downhole geochem samples from 319 envelopes. Then we have over 11,000 drill holes with the lithology logs captured and 1,000 drill holes with petrophysics logs from 222 envelopes. And the surface samples, nearly 155,000 samples with geochemistry from 50 envelopes. All the data was available for all competitors for the Goller Challenge to use it. Next year, GP2 program, next audit. We've done, I don't know, something happened here, it's not showing all of them. We've done over the 1,930 tenements, we did the audit on all expired tenements and ELs. So what we end up with the team #2, with the staff members Charlotte Mitchell and Alex Korik, and we have another 10 students supervised by Alex. We did all the stats, we can see there. Not sure why it's not showing there. It's showing here on my prints. Here we have the delivery in the database. What we put at the end of this GP2 drilling program, we added the lithology logs from 210 envelopes, about 5,536 the drill holes, and 1,083 new drill holes and almost 25,000 downhole geochemistry captured from 116 envelopes. Surface samples was quite a bit of challenge, 17,244 new surface samples. We had to use OCR on some typed envelopes, and it was very much time-consuming and labor-intensive to capture this one. We also updated almost 2,000 drill holes at the core library with 52,605 geochemistry results. That's a great achievement. Next audit, conducted early this year in April, May. I had another 2.5 months to complete it on mineral deposits of South Australia. This was our main project running at the moment in the Geological Survey. 1,065 envelopes being checked, 515 exploration tenements and 96 special mining leases being audited. We had the stats. We have in between 83 to 86% of the data to be captured from both ELs and SMLs. And we did the audit on every single mineral deposits here. We can see highlighted there. We put different color codes for us, to group the tenements and do the audit. The work is in progress, but here is going to be, a summary slide. showing what we have in the database. It's here with the blue. We added digital, non-digital, handwritten data. We have the numbers in the database. We are quite happy with that. We are not happy with these ones, with non-digital and handwritten data. If we add all of them, we can end up with over 30,000 drill holes, not digitized, over 200,000 downhole geochem samples in handwritten format, and over 100,000 surface samples to be digitized. This is a big job. Even if we have additional resources and we might put together team number 3 to do this, it will take probably between 3 to 5 years to complete. So what else we did? We're just looking at the state, from where we have, the ELs with the highest number of the drill holes. So we have to prioritize around the Mangansen area and around the Trinity mine area with the orange, over 1,000 drill holes to capture. Then we are checking with the lithology logs in handwritten format. They are basically all over the place from both ELs and special mining leases. And the next one, the surface samples to capture, again, large area from where you have to georeference all the surface stream sediments, soil, calcrete, etc. from the existing plans, and it's time consuming. We need more resources for that. Of course, we can't work this in isolation. We have to check what we have at the core library. So I'm showing you these maps, in particular for the explorers here in the room, because I did the stats in the mid of November, how many mineral drill holes we have at the core library. This is not showing how many petroleum wells or how many water bores we have at the core library. Mineral drill holes only. So I grouped them based on the final depth. So we have only 165 drill holes around the Stewart Shelf area and a little bit scattered from the state, with the depths between 1,000 and 2,365 meters depth, while the rest are in the shallow one, and in particular, when you're looking at the drill holes below 100 meters depth, they represent about 70% of the drill holes at the core library below 100 meters. What this means, exploration in the past has been done mainly in the shallow area where we find, existing mineral deposits, but now these days we might need to focus exploration on much deeper area of the state. And when you're looking at this map, you can you can create your own map on CERIC using the layers. We heard from other presenters today. You can put some more information about the drill holes, and when you're looking on your tenements, you can see where will be some areas so you can plan a deeper drill hole, because this will add value to the virtual digital core library. What else do we have at the core library? I'm putting some maps together. We need to capture more data. In the blue, we have in the database. With the red, we need to capture. So there are mineral drill holes at the core library. We need to add geochemistry for over 20,000 drill holes. What else? We need to add lithology logs. In the database, 7,000 to capture from 26,000 lithologs. Handwritten format, difficult to read, to understand. What's next? We need to capture petrophysics logs. In the database, not in the database. So this is labor intensive, and to create a virtual digital core library, it's a huge, big ambition for our geological survey, and hopefully it will come through, but it takes time to complete this. Of course, we cannot work in isolation, so we have good collaboration with industry. So I'm showing you here 2 examples. Collaboration with Tim Butt from Havila Resources. We've been at the core library together. We saw, from this historic tenement around Trinity mine area. There are some good auger drill holes, some with elevated values of silver, but we have also copper and manganese there. We do some georeferencing together. To date, I just updated yesterday some of the drill holes. There are over 1,000 drill holes with georeference from the core library, but we still have a lot, about 3,000 drill holes to go to georeference from these existing plans, like you can see there. The other one is around Mangansen area. We started a collaboration as well early this year with Coda Minerals to give us some updated digital data, but we put also lots of time and effort to capture the rest by ourselves. We added new drill holes with the chemistry, and today we have about 291 additional drill holes found at the core library without location, without georeferencing, that are available now for the core inspection and to do maybe whole rock analysis. So it was a good project, and our colleague Mirella Terrones has a poster, so feel free to go and have a look at the poster about the Mangansan area and the work she was doing in that area. In the next couple of slides, I'm going to show you some mineral prospectivity maps, again, using some surface samples from the SERIG. So in the surface samples, I included rock outcrop, calcrete, soil, stream sediments, lag, loam, vegetation, costian, etc., anything that is to the surface or just auger a little bit below the surface samples. And I'm just creating, some mineral prospectivity maps using geochemistry from legacy data. We heard earlier today, we don't have many potential for the lithium in South Australia, but there are some elevated values around there, around the Barra, in the outcrop samples, up to 4,420 ppm. It's close to Adelaide. It's worth maybe a short project to go and revisit and taking more samples. Then we have for the copper in the surface samples, it's quite elevated, between 10 to 20% copper in the surface samples. The surface samples are enriched in copper. They are generally following the pattern where the copper mineral deposits are in South Australia. So it's good we have also the expression in the surface. For the rare earth, I did 2 maps for neodymium and dysprosium, looking again at the surface samples. Seems that Barra seems to attract quite a lot of outcrops with some elevated value in the rare earth. The same, around Kangaroo Island, just below, they've been mentioned by companies in the past. So it's good to go to revisit and do some more projects with some rare earth. And the next map is going to talk about cobalt and nickel. They go quite nice together, following, the existing mineral deposits in the state. But we have also some areas a bit cluttered there around Cooper Pedy area. So I was curious to zoom in, see what's in there. So this is where we have elevated values of cobalt and nickel. So in the soil samples taken back in 1989 by Western Mining Corporation, it's good, to go there, maybe taking more samples, looking, for the source of this cobalt and nickel in that area around Cooper Pedy. So in summary, looks like the Geological Survey South Australia do value and recognize the importance of the legacy data. We did complete statewide audits. We use the data in all collaborative projects. To date, we have about 300 envelopes from legacy data that are digitized and used in different projects. We have ongoing projects, and for me, the digital virtual collaborative is a big ambition. It takes time and energy to do this, so we need team number 3 for that one. And for the critical mineral audit, about 665 envelopes to be digitized. Again, it's a big, big job on its own. Of course, I cannot finish my presentation without a big call out for industry to help us with legacy data from their tenements. Because next time when you are going to the core library and you're looking at these Australian selections, the drill holes, they are not on SERIG, they are not digitized. Reason why, you don't have the data, nothing is digitized, but you might find there the next, maybe, copper deposit. Thank you very much. That's all for me.